All right, guys. So, Unit 1, quiz number 2, piecewise functions from a graph and solving algebraically. So, for our question with the graph here, the biggest thing I want you to see and really call out is going to be that, oh, it's not going to be right. Let's see if I can make this work. That open circle right there. That's the only thing that's a problem. Everything else, solid line is just as good as a solid circle. Solid circle does exist. But that open circle is like a big pothole. You can't stand there, so that does not exist for this function, for the domains that were set for this function. Now, going through our question, so f of -3, that means the x value is -3, so we're going to come over here to -3. The function is down below, so it's going to be -3. For 4, we're going to come over to 4. Our function is above it, so we're going to come up here. And you're looking for the output or the y value when x is 4, which happens to be a positive 4. At f is -1, again, our function is an open circle, so there's no solution here. So no solution, not 0. 0 is a place on a graph. So if there's an open circle, that's no solution, not included. Error is what you'll also see a lot of times in a calculator and things of that nature. So f of 0 means when x is 0, we're going to go up and find our function here, and so it's going to be a positive 1. So whatever is in the parentheses is your x value, and you are looking for the y value of where that function exists for that input. All right, so for our algebraic solving, this says when f is -5. So when x is equal to -5, we have to pick our function using our two domains. This is x is not 4 and x is 4. -5 is not 4, so we're definitely going to focus on our top function. And that's a -x plus 1, and we're going to plug in a -5. Those double negatives make that a positive 5 plus 1, so our answer is 6. So when x is -5 for this piecewise, you would find y to be a positive 6. So same for another graph. So find f of 2. So when I come over to 2, that would be here, and then we're going to go up and look where our function is. Open circle means it doesn't exist. This is a solid circle, so it's looking good. And then as we go up, we see another open circle, so that's no good, and that's no good. That solid point at 6. So f of 2 is equal to that positive 6, because at that coordinate 2, 6 is where this function, piecewise function, or portion of these functions exists. So when x is 2, the only time it works is when y is 6. So is the value -1 part of the domain of this function? So does that x value exist is what that's asking. So at -1, I go up, there's an open circle, so it does not exist. Big no, because there is an open circle, and that means that x value does not exist for this function at all, as long as there's an open circle. If you could keep going up and there's another black dot or there's an extended line somewhere else, then it would exist. For this function, your domain would be -3 included to -1, but not included, because that's an open circle, and then -1 to 0 included, because it's a solid circle, and we're using our x values because we're talking about domain, then not inclusive of 2, because that's an open circle, all the way to +4, and it is included +4 because that is a solid circle. Another one of our graphic practice ones, so we're going to go over to 5, and here it is. If you want to check and make sure your function's not above it as well, nothing's up here, so it has to be here. So at f of 5, when x is 5, y is going to be 0, because it is an x-intercept. It's where it crosses the x-axis. So that point would be 5, 0. All right, that's going to be it for this video, guys. Hopefully they're starting to make more sense, and we cleared up